Hey everyone. I thought we could look at some more problems today. This is assignment 46A. 46A, if we have time or you need more practice with scatter plots. This is the one that I'm looking at. Yeah, I think I'm looking at this one. Yeah. I've got Austin, Texas, and I've got U.S. petroleum imports. I know it's old data, but my degrees are in history, so I'm okay with old data. T equals 0 is 1973, so I'm going to go 0, 1, 2, 3, 4, and so on. If you don't do that, what happens is then this is the year 1973 for most students. They type in 1973, 1974, and so on, which means when they go and find that original amount in their model, the original amount takes them back to, yeah, it's just not a good thing. So let's take a look at this data and our calculator, and we're going to do 0, 1, 2. Okay, so stat, edit. Remember to up arrow, hit clear. When you're done saying how come nothing is cleared, remember that you need to hit enter. And up arrow, clear, and enter. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, 0. Okay, yeah, I wonder how long that took. Oh, look at that. I didn't actually make any mistakes yet. That's amazing about this stuff. 14.2, 14.5, 14, 16.5, 18, 17, 17, 16, 15, 14, 13, 15, 12, 14, 16, 17, 18, 17, 16, and 16. Remember, the stuff in this column should be the same number of objects as the stuff in this column. Otherwise, you end up with a mismatch error when you try and do this. Okay, and so I want to get a scatter plot going, so I'm going to take out these other models, and I've got my scatter plot turned on. So if I do zoom, stat, which I believe is number 9, I should see this picture. Now, this data isn't as pretty, uniform, nice as some of the other data sets we've looked at. But this is actual data, and actual data is just going to be actual data, which is all the more reason why we're talking about not finding the line, but finding a line of best fit. What's the one that makes the most sense? And so I think I see a high point and a high point. And for me, I don't even see necessarily low points. I mean, I think that's a low point, but I don't know what the heck's going on over here. I kind of also want to make this suggestion. Should I throw away that point? Should I maybe say that this is the data, this is the trig function? Or really, do I need to include these two lower? I mean, if we're willing to say my graph doesn't have to pass through that's kind of an outlier, then why can't that be an outlier, just in the opposite direction? So I don't have a good answer for you on that, except to say that I think that when you build a model and graph it with the data, that you have an intuitive sense of whether you think this model is good enough or not. And certainly, Mr. Paz and I will happily let you know if we think it's good enough or not, if you show it to us. But I think this is definitely going to be a case where we're just going to have to, there's no way we're going to be able to hit all those points. And sometimes that's a little release, a little joy. Okay, so let's think first about this model. Okay, I've got high points up here. They seem to be 18. They're both 18, so I'm going to go with 18. And then down here, it seems that my lowest point occurs with 13. And then I have this 14 above it. And I think for our first attempt at this model, I'm going to use 13 and I'm going to use 18. But I think the second attempt, I'm going to throw away both of these points and look at, I think it's 15? Yeah, 14.5 maybe? I don't know. Let's, this is like the only time I ever use trace because it will hop from one point to the next. Okay, so 14, yeah. I think I want to go to 14 on this and then just drop the 12 and 13. But that's going to be the second model. The first model I'm going to do is going really just as the data shows. So my D value, this is oil that we're dealing with. My D value is the average of the high and low Y values. So 18 plus 12 divided by 2, it's 15. And therefore my A value, high Y minus D, gives me 3. Often students get these two confused, so watch out for that mistake. C. Well, for me, I see a positive cosine starting here. And if I back arrow onto that point, I see that my C value would be 4. Okay, so C equals 4. You know, if you saw a negative cosine, you'd want to start here. I really don't have a sense of where the midline is yet. So I'm not comfortable using a sine graph here for a different C value. The last one we need to find is B, and we know because we're using a cosine graph, period is normally 2 pi. Well, what's the period for our data? Well, that's 4, and let's hop over to that other high point there, and that point says 16. So 16 minus 4, 2 pi over 12, or pi over 6. Okay, so let's type that into y1 and see if we like it or not. 3 cosine pi over 6, x minus 4. Don't forget close 2 parentheses there, plus 15. Okay, remember to check your mode and make sure you're in radians. That's definitely something to think about. And graph. So here's my first graph. And here's what I notice about this first graph. I see that this line over here is a little left, more left, very left of those points. And over here, I see I'm also to the left of those points. So my first inclination is to think, well, maybe what I want to do here is shift my graph to the right a little bit. You know, we had 4. What happens if we do something like 4.5? Second, insert 0.5 and graph. Wow. That, you know, I like that I got closer to these. I'm bang on with these now. So here you have to decide, A, do you feel like this is good enough? B, B, if it's not good enough, what would you do? Well, I think it's pretty good, but I'm wondering, you know, maybe what we need here is a little narrower. And that, why do I think that? Because this point is spot on, and this point is not. Like, I know a C value when everything, the curve is the same distance from every point, and I just need to move it over. But here, I still have a gap here. And so maybe I need to try and change my my b value here a little bit. Um, yeah, I will say that yeah, I think I kind of want to. Well, so here's that thing. Oh, by the way, if I changed my b value, it's probably also going to necessitate changing C again in response to changing the B value. So don't be surprised if that kind of thing happens to you. All right. So let's change that B value. And what do you think we should do? Should we compress or should we stretch? What would be better? In fact, I think to facilitate this, I'm actually going to push even further, go 5.5 and see what that does. Yeah, I think 5.5 was definitely too much because now my graph is again, I see so many points here that I'm missing, and these are missed on the same side. So turn that into 5.0 and see if I like that. I know I'm supposed to be doing the B value. I'll get there. I'll get there. Ooh, I like that. That's really nice. It's just a little too far that way. So how about 4.9? I don't know. I mean, I thought maybe that changing the B was going to be the issue here, but it looks like the C value, wow, I like that. Let's just try and change that that B value and see what it does. Okay, so I know when that B is bigger than 1, when B is bigger than 1, I'm compressing the graph. Because remember, I'm dividing all the x's by that B value. And so if I divide by 4, suddenly, whoosh, everything gets a lot closer. And so if I want to have some sort of, this is compress. If I want to have some sort of expansion, then I'm going to use B between 1 and 0. Well, what do you think we need? Do you think we need to push this in a little closer, or do you think we need to draw it out? Well, let's see what happens if we draw it out. Now, if we draw it out, we're expanding the graph, and so I want a B value that is smaller. A smaller B value, or a larger denominator on our B value, will stretch the graph horizontally. So what if we change that from 6 to second insert 6.5 graph? Oh, well, I definitely see it stretched because look how far away I am from there. And here's the thing that I recognize about this B value. I mean, all these points line up beautifully now. Well, if I try and change the C value, tap, tap, so that I can hit those points, I'm now going to miss those points. So I don't think changing the B value is something that particularly helped me. Let's go back and look at, since we weren't really sure which way we were going to go, this way or this way, let's try 5.5 and see what we think about that. Remember, our original denominator was 6. Well, yeah, I don't know. I can't say as I quite like that one more than what we had. I'm going to back arrow on to the line type. And I'm going to choose dotted line. And then I think I'll put in that other model that we were just toying with, which was 3 cosine pi divided by 6, x minus 5.5, close two parentheses, plus 15. Okay, so which one do we like better? This is the one that we tweaked with a different b value. And this one has our original b value. I kind of feel like I want to do something in between the two. So that was pi over 6, and this was 5.5. I don't know, let's Let's maybe change that to second insert 5.75. Do we like the second one better? Which do we like better, the first one or the second one? I think I like the second one, but I think I want to change my C value now on the second one. Oh, that's what, yeah, I've been changing B, but let's change this. I want to move a little to the left, so I'm going to go back to 5 here. That's, wow, I don't know, I like this over here on the dotted one. The others look very similar. I think the solid one, the second graph, is better here through these points. Yeah, I don't know. And this was the one I had written down in my notes from last year. Let's see what we think about this one. I had 2.5 cosine pi divided by 6 x minus 4.5 plus 15.5. Wow, a bunch of different values. So, oops. Oh, that's supposed to be a pi. There we go. Graph. Okay. Do we like that one? Yeah. Do we like solid one? No, I don't think I do. And what about this third one? Oh, look, the third one is this one. Yeah, so I'm actually gonna turn off these other two and just graph the third one. So the third one is where I got rid of 12 and 13. Wow, I really like that. I know that if I tap it to the right a little bit, I'll get a little, but I'll catch that a little more. I'll get closer to that point, but I'd move further away from those points. And I really don't think I want to move away from those points anymore. But maybe. So let's see if we go this way. How about 4.8? And this tweaking process is definitely for us. I mean, there are in fact mathematical tools that you can use to help you build better models. Yeah, there's lots of tools. But for us, this is more just sort of a taste that we can actually use our math to model real world data. Do I like that one? I don't know. See, because I think I just want a little bit bigger. I just want to clip those 2 points a little more. And part of me is thinking that if I pulled the graph that way, I could get lower without having to change the x's. So let's take a look at our amplitude. It's 2.5 here. What if I made it 2.7? What do you think? Wow. Well, so I'm kind of bummed that I'm not hitting these points, but I'm sort of catching that one, and I really like how it works in here. And that's another thing I would say about building a good model. What do you want your model to do? Do you want your model to extrapolate? By which I mean, do you want to use this model to predict events either before 1973 or after 1992? Or do you want to interpolate? Do you want to see how good your model is at catching the actual data? Yeah, I think that's something to be concerned about when I do these problems. How many barrels 1987? Oh, well, that's interesting because that's interpolating, and we have a value for 1987. So let's see what happens when we plug in this 1987. Now, wait a second. This was 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I want to plug a 14 into this function. Go over to my table, and I'm sorry, they said 1987, and I said 14. Let me count again. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 it is. Okay, so I plug in a 14 here, and I get 15.782. Well, the value recorded is 16 quadrillion barrels. So, granted, I'm 200 million barrels off, or billion barrels off, and that's like a lot, but actually it's kind of close to 16. So maybe that's good enough. Let's see what happens when we use our other models. These are the other ones that we had looked at. And I think I'm most enamored with the third one, but let's see. If we plug in a 14, we have 16.4, and we have 15.61, and we have 15.78. Well, that third one is the closest to the actual value of 16. That's kind of cool. So I think I'm going to go ahead with the third one. But again, if I'm grading you with plus or minus 2, I think you have some leeway there. Okay, so we're going with this one, and the last question, they say, use the model to determine how many barrels of oil would be imported in 2015 if this trend continues. Okay, so I think we said stat edit. I think we said that our last one was at 19. Yeah, 19. So that's 19. And then 19 and 2015 is going to be 19 plus 8. No, 19, yes, plus 8 plus 15. Why didn't I just do 2015 minus 1973? Yeah, no good reason. I'm going to borrow 1. That's 11. I get 4. And I have to borrow 1 from there to make that 9. Okay, so I've got 42. So let's plug in a 42 into our table. And 42. Well, so that would be my answer, 17.84 quadrillion barrels. All right, any questions about tweaking? Yeah, well, let us know if you do. One more. We've got the data set that I'm looking at here is Austin, Texas. It's very interesting. Something has occurred because I have here this oil thing as the first problem, and here I have the oil thing as the second problem. And here I have Boston, and here I have Austin. It's very interesting. Is there a back? Oh, look, there's a back. Ooh, unemployment figures. Yeah, so, I find it interesting that we can have this data as consistently as we do, being cyclical, being periodic, and it makes me wonder if things like this, like how can our oil use be sinusoidal? I thought as we had more people, we would just keep using more oil. But this 20-year stretch of data seems to suggest that we were fairly constant in our use. Maybe you want to look at what, oh, but this is also imports, not total usage. Oh, okay. Well, then that's a whole different question. Like, that depends on whether we're fracking or not. And, yeah, so I think we'll just move on to Austin. Again, I'm going to go with 0, 1, 2, 3 when I type this in. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Stat, edit, clear. All right. And go, clear, enter. 51, 55, 63, 67, 77, 86, 90, 84, 71, 52. Okay, so again, we're going to do zoom stat. Okay, here's our graph. You know, it kind of looks like a negative cosine to me. Maybe a positive cosine starting up here. Notice how the data is sort of squished over or leaning over, like that this high point isn't centered. Yeah, I think that we're going to just find this to be a struggle. Yeah, I think we're just going to find this to be a struggle that we're going to have to bear up to, and we're just going to have to live with that. So let's see what we can come up with for a d value. And yeah, maybe we'll just do negative cosine. I don't know. Let's see when we get there. Oh wait, we're there now. I'm supposed to decide that now. I kind of like positive cosine because I can actually see that that's the high, as opposed to here I don't know if it actually goes down a little lower. Yeah, so I think I'm going to do positive cosine. Okay, d value. So my high point here was 90, and my low point was 51, and we divide by 2. So that's 141 divided by 2, which is 70.5. My a value will be 90 minus 70.5, or 19.5. My c value, I'm going to use trace to that, and I see 6. You know, since both of these are 90, maybe I actually want to do 6.5. But remember, this graph is sort of leaning to the right already, so maybe I'll actually want 5.5. So I'll go back to 6, and we'll think about pushing one way or the other. And then finally b. Okay, 2 pi over the period. Well, here's the thing. I know that you want to do 11 minus 0 for 11. But really, I want to say there should really be another January here so that you could go from January to January. Look, we know that there are 12 months in the year before the cycle starts again. So the period's 12. You know, there might be some small tweaking of that, but yeah, generally speaking, with these events, we're going to have pi over 6. I thought it was interesting on the oil problem that we just did, that p-value also started as pi over 6. I know, right? Okay, so let's type in what we've got. I guess I want to get rid of that one. And I'm going to type in here 19.5 cosine pi over 6 x minus 6, close 2 parentheses, plus 70.5. And let's see, whoa, second insert plus. Okay, and let's see how that goes. Wow, that's pretty good. That's better than I thought it was going to be. Okay, well, so maybe we do want to go to the right a little bit. So maybe 6.5. Let's see if we like 6.5 better. Y equals 19.5 cosine pi divided by 6, yes, parentheses, x minus, 6, and I want 6.5 here, and plus 70.5. Okay, which one do you like better? Ooh, I don't like that. Yeah, that's too much shoving to the right. So can I get something in between 6 and 6.5? How about 6.2? That's not bad. That's our first one. I wish it was closer to those. Oof. Yeah, I don't know. going to turn off the first one and just judge the second one. You know, it's interesting because I see this little gap over here, and I see the same gap over here, and so I think maybe moving it to the right. But moving it to the right just brings us back to this one. I don't know, maybe we like that one better. Here's our original guess. Oh, did I turn off the graph? Yes, I turned off all the graphs. There we go. Yeah, you know, I kind of actually really appreciate how there's like 2 on the left and 2 on the right here. So like I really do feel like my line is threading between those 4 points. So I think I'm just going to go with this. Okay, we've done the first 3 parts, A, B, and C. Part D, use your equation to predict the temperature in Austin on June 15th and September 15th. June 5th, I don't know, but it's, yes, June 15th and September 15th. Okay, so remember, we started with January, so that was 0, 1, 2, 3, 4, 5. So 5 point what? Well, 30 days, half September, April, June. So we want 15 over 30. Well, that's half. So I'm going to have 5.5 as my input. 5.5. Now, what about September? Well, if this was 5, 6, 7, 8. I'm going to type in 8 point something for September. 30 days has September. Oh, same. Because 15 over 30 is going to be, again, half a month. So let's go over here to our table, and let's type in 5.5. And then we get 89.338. That doesn't surprise me for Boston in June. And 8.5. And I get 75. Ooh, definitely time for a light jacket. 0.4. 75.55 degrees. Now I don't have those halfway throughs that I might want to see. But if I look at June and July and I see 86 and 90, that 89.234, I'm sorry, 89.34, yeah, I could believe that. And then our other value for September, well, September we were 84 to 71, and we've got 75.3. I feel like, yeah, I'm smack dab in a range where I expect to be, so that's good. And then the last question, on what days is the temperature approaching 65 degrees? Well, 65 in this problem is an output. And what was I supposed to do with outputs? I was supposed to graph my output. So I'm going to graph my output of 65, I'm going to graph my model, and I'm looking to find points of intersection. Second, calculate, intersect. And I get 2.453911. And that was 2 points. So that's March. How many days does March have? 30 days has September, April, June, and November. All the rest have 31, except February. So I'm going to take that 0.453911, and I'm going to multiply by the fact that there are 31 days in that month. So second quit, and 31 times 0.45391. And I end up with something I did not expect. Oh, there's a decimal point there. So second entry. Let's go back and take out that decimal point and then do this. So I've got 14.07. So that's the date, right? I mean, I've got March 14th. And again, if you're within 2 days of that, we're fine. If not, then we should probably have a conversation about tweaking some more. And wasn't there another one? Yes, find the days. We only found one of them. There's another one over here. Second, calculate, intersect, bring my cursor close to that point of intersection. I mean, just close enough so that my calculator doesn't think I'm looking for this one. I think getting past that maximum should probably be close enough. Enter, enter, enter. And I get 9.546089. Well, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're talking about October for 9. Now, 30 days, I September, November. That means October. Oh, yes, Halloween is 31. So I'm going to do 31 times 0.546089. And what happens? Well, 31 times 0.546089. And I get, I'm going to go with 17. October 17th. I mean, it's very late on the 16th. So, close enough. Because we're just needing to be within 2. All right? Any questions about this? Okay. You see there's one on the back. How are we doing for time? 36 minutes? Yeah. I think I'm going to skip the one on the back about unemployment. Yeah, I mean, compared to the economic meltdown 2000, 2008, and more recently COVID, yeah, this data is way out of sync. So I think I'm just going to skip that one and say, I think that's it for today. If you have more questions or want to have more practice, let Mr. Pauser I know, and we can help. All right, take care, everyone.